All right, good morning, guys. So today we're going to talk about exponent rules, and this is something you guys did probably last year and probably even in Algebra 1 as well, but let's just do it again as a quick reminder. So we're going to talk about what you do when you have stuff like this or like this, when you have to figure out what to do with the exponents. So we have 5 rules here that we're going to talk about. And then you guys are going to work on a worksheet and see if you guys can simplify problems like this. All right, so first we're going to talk about what you do when you're multiplying and you have the same base. So notice both these bases are x, and then your exponent, right, is a and b. So those can be different numbers or even the same number, it doesn't matter. So we're going to talk about what you do when you have a situation like that. How do you simplify that? So we're going to look at a couple things first. Now, you don't have this paper, and that's perfectly fine, so you just need to watch this. So we have f to the 6th times f to the 5th. So if you think about this, if we expand this, right? So when we have talked about exponents before, right? So if I have x squared, that means x times x, right? We have 2 x's because this is x squared. If I have x to the 4th, that just means we have 4 of them, maybe. All right, so we have 4 of them, right? Because this is a 4. So we have 1, 2, 3, 4. Okay, so if we look at this, if we have f to the 6, so that's 1, 2, 3, 4, 5, 6. So that's f to the 6. And we're multiplying this by f to the 5th. So 1, 2, 3, 4, 5. So then if I'm simplifying this, I just need to figure out how many f's I have here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this ends up equaling f to the 11th. All right, so what did we do with this and this to get to f to the 11th? We added them. So if we look here, we have y to the 8th. There's y to the 8th, and then we have y squared. So I have 8, 9, 10. So this is y to the 10th. Again, what did we do to these exponents? We just added them. D to the 3rd, 1, 2, 3, and then d to the 1st, 1, 2, 3, 4. So we have d to the 4th. So if there's no exponent there, right, that's just 1. Okay, so 3 plus 1 gives us 4. So be careful, this is not a 0, this is a 1, okay? All right. So if we write that out in rule form, so if we look at this, we have x to the a times x to the b. So we're going to write that as this is x, the bottom number, the base doesn't change, and that becomes a plus b. So you're going to be adding. So if you're multiplying, we add exponents. So if we look over here, I have h to the 2nd times h to the 6th. So this would be h, and I add those two together. 2 plus 6 gives me 8. Now this one, it looks a little bit more confusing, but it's not. So we're going to start with the big numbers, like the whole numbers. You're still doing normal operations that you normally would do with those, right? This is -2 times 7. We're not adding the whole numbers, the big numbers. It's the small numbers, the exponents, that you end up adding. So if I have -2 times 7, that gives me -14. And then I have a squared and a to the 3rd. So I add those. 2 plus 3 gives me a to the 5th. And then I have b times b. So b to the 1st, b to the 1st, that's b squared. Okay, so you just take it piece by piece. Now, notice that I did not combine the a squared with b, right? They have different bases, so we don't combine those. So it's like terms. All right? Okay, so then we're going to look at the power rule. So that's called the product rule. It's okay that you don't know the names of the rules as long as you know what you do with it. So when we multiply, we add them. All right, so now let's look at when we're taking a power and raising it to another power. Okay, so what I'm doing is I'm taking m to the 3rd. So I'm going to write this out. So I have 1, 2, 3, right? And when we square something like 2 squared, that means 2 times 2. So here I'm taking m squared, so I have m cubed, and another m cubed, and we're multiplying those together, right? So now if I look, I have 1, 2, 3, 4, 5, 6. So now I have 6 of them. So this is m to the 6. All right, if I have a squared, that's my base. So again, this is like saying 2 to the 4th, right? 2 is my base. So right here, my a squared is my base. So I have a squared, and I'm going to do it 5 times, right? So we're going to write this out as a times a. There's one of them. A times a, there's 2. There's 3. There's 4. And there's 5. So I have 1, 2, 3, 4, 5 a squareds. Now, if I want to simplify this, I look at how many a's did I end up with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this equals a to the 10th. All right, hopefully you're starting to see a pattern. All right, so x to the 4th is my base, and I'm going to do that 3 times. So 1, 2, 3, 4. There's one x to the 4th. 1, 2, 3, 4. There's another x to the 4th. And there's my third x to the 4th. So then I have 4, 8, 12. So this is x to the 12th. So what are we doing to these two numbers to get to 12? What did I do to these two numbers to get to 10? What did I do to these two numbers to get to 6? Hopefully you see that you are multiplying those. So here, without having to write it out, p to the 6 raised to the 2nd, I'm taking these two numbers and I multiply them together and I get p to the 12th. All right, so when you take a power to a power, you are going to multiply. So here I have x to the a raised to the b. I'm going to take these two right here and I'm going to multiply them. So this would be x raised to the a times b. So you're just multiplying this. So you just multiply exponents, power to a power, we multiply. So here we have x squared raised to the 3rd. So power to a power, I'm going to multiply. This becomes x to the 6. Now here, notice that this is in parentheses. Okay, so if we have parentheses, I'm taking all of this negative 2m to the 5th. I'm doing that 2 times. Right, so this is negative 2m to the 5th times negative 2m to the 5th. Negative 2 times negative 2 gives me a positive 4. M to the 5th times m to the 5th, or right here, we can multiply those. That's m to the 10th. And then I'm going to rewrite this part because I haven't done that yet. Now, we have the same base, and we're just multiplying, so we add those together. So 4m to the 13th. Another way to look at this negative 2m to the 5th squared is that you distribute this to everything on the inside, that power, and it stays a power. So this is negative 2 squared, m to the 5th, all of that raised to the 2nd. Okay, and so you can do that stuff on your calculator. Be very, very careful with negatives. Always put the negative number in parentheses and the exponent on the outside to be sure that your calculator does it correctly. Okay? All right, and then we have division. All right, so hold on one more time, sorry. So when we're multiplying, we add. When we're taking power to a power, we multiply. Now we have division. All right, so if I have m to the 7th divided by m squared. So I'm going to do 1, 2, 3, 4. So there's 7 m's. That's m to the 7th on the top. And on the bottom, we have m squared. Now, something that you learned a while back is that when you have the same number on the top as on the bottom, they cancel out when you're doing division, right? So this m is going to cancel out this. This is going to cancel out this. Now, the leftover m's are all on top, so that's going to be a whole number. If your m's are left on the bottom, then that would be a fraction. So I have 1, 2, 3, 4, 5 left. So this is m to the 5th. Here, I have k to the 8th. So I'm going to write out 8 k's, and then k to the 3rd. And then we go 1, 1, 2, 2, 3, 3. I'm left with 1, 2, 3, 4, 5. So this is k to the 5th. All right, so be thinking, what am I doing to these numbers to get this number? What am I doing to these numbers to get this number? So I have 1, 2, 3 b's and 2 b's. I'm going to cancel, 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 cancel. I'm left with, this is just b, or b to the 1st, right? But we don't have to write the 1. It's not necessary. All right, and then here, what happens here? It's the same number, right? So if Sorry, I gotta write these all out. So cancel, cancel. All of these cancel, right? So I'm left with 1, right? So we learned with fractions, if you have the same thing on top as on bottom, like 4 over 4, then that equals 1. Same thing with exponents. If you have the same on top as on the bottom, everything cancels out, so you're left with just 1. Okay? All right, so what was the rule? What are we doing here? What are we doing to these numbers to get our exponent? Hopefully you said subtracting, right? So with division, we're going to subtract. Okay, so if I have this, I'm then going to write this as x. This is a minus b. Now, it's always the top minus the bottom, okay? So subtraction, the order matters, so it's always top minus the bottom. Okay, so if we look at our examples over here, so on this one right here, we're going to start with the whole numbers, right? We don't subtract those, right? This is division. You guys learned this back in elementary school, right? We're dividing whole numbers here, okay? So if I take 27 divided by 42, now that doesn't divide evenly, so when I do it on my calculator, so 27 divided by, 27 divided by 42. I get this crazy decimal, right? Well, I don't want that decimal. I need it as a fraction. So on my calculator, I hit, let's zoom out. I hit math. So notice that I haven't hit anything else. I got my answer. I hit math, enter, enter, and it gives me a simplified fraction. So this is 9/14. All right, so 27 over 42 simplifies to 9/14. Now I look at my exponents, and this is where I subtract. So I have 5, and this is just x, right? So we know there's a 1 there. So 5 minus 1 gives me x to the 4th. So it's a positive number, so it's going to stay on top. So x to the 4th. Okay? All right, down on the bottom. So we're kind of doing a couple rules all in one. So we have y squared raised to the 2nd. So power to a power, remember we said we multiply. So this is y to the 4th over y to the 4th. And remember from this paper, we said that if you have the same thing on top as on the bottom, that it always equals 1. So then this equals 1, okay? Now, when you subtract, if it is a positive number, it goes on the top. The exponent goes on the top. Now, we'll talk about what happens when it's negative. So we have here, we have a negative exponent. Now, we don't like negative exponents at all, right? So we have to get rid of the negative exponent before we can start doing anything with it. So to get rid of a negative exponent, we throw all of this to the bottom of a fraction and drop the negative sign. Again, we throw all of this to the bottom of a fraction and get rid of the negative sign. So we always put a 1 on top, and this would be x raised to the a. So I put it on the bottom of a fraction, and I lost the negative sign. Okay? So when you have a negative exponent, it goes to the bottom of a fraction. All right? So if we look at this right here, negative 5x squared. Okay, so this is attached to only this. This negative 2 is not attached to this negative 5 because there's no parentheses. Now, if it was like this, then all of this is being raised to the negative 2. But it's not. There's no parentheses. So it's just with the negative 2. So to get rid of this negative 2, we put it on the bottom of a fraction. I'm not going to touch this at all. This is a whole number, so it's going to stay on top. All right, so whole numbers stay on top. If it's if it's a piece, then it goes to the bottom. So if we look at number 2 again, we start with just our numbers. We're going to ignore those. We do not throw anything to the bottom of a fraction. We don't subtract those. They're just normal numbers. So 4 divided by 8 is 1/2. Now, we said from up here, we know that when we're dividing with exponents, we subtract them. So if I subtract these, this is 2 minus 5, which is a negative number. So when you subtract, if it turns out to be negative, we put it on the bottom without the negative sign. Again, you subtract these, and if it's negative, you put it on the bottom without the negative sign. Okay? This rule right here is the hardest rule. This is the trickiest one. okay? So it's going to take some time getting used to. You're going to have to practice it. But again, all you're doing is when you subtract, if it's negative, it goes to the bottom of a fraction without the negative sign. All right, and then this last rule is the easiest rule. Any single number or variable raised to the 0 is always, 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 always 1, no matter what. No matter what. So I could have 542 raised to the 0. That equals 1. I could have y raised to the 0. That equals 1. I could have 15 raised to the 0. That's 1. Doesn't matter if it's a number or a letter. Anything raised to the 0 power is 1. Okay? So if we look here, notice again, this is not in parentheses, right? So this exponent is only attached to the x. So x raised to the 0 is 1. And then we have that times 7, so that just gives us 7. All right? Now, if it was like this, 7x raised to the 0, then this would equal 1. Okay, so notice the difference. This one does not have parentheses. This one does have parentheses. So that's the difference between the two. All right, so if we take a look at this one, we've got power raised to a power. Again, remember, power raised to a power, we're going to multiply. So 4 times 2 gives me 8. So we have w to the 8 over w to the 8th. Now, we've already talked about this, that when you have the same thing on top as on the bottom, that it equals 1. But if we did the subtraction rule, we're also going to get 1. 8 minus 8 is w to the 0, which again just equals 1. Okay? So anytime you subtract, you get a 0, or if it's already the exponent is 0, it just equals 1. All right, so you're going to keep this paper out in front of you, and you're going to work on the other worksheet. And if you have any questions, Miss Bosie's going to come around and help you. You guys can do this. Take your time. Take it piece by piece.